All right, in this example, we're going to be taking the following base 10 number, 59,951, and we're going to be converting this to hexadecimal, or base 16. So in our regular base 10 numbers, each position is a power of 10. So this would be 10 to the 0 or the ones place, 10 to the 1 or the tens place, 10 to the second or the hundreds place, and so on. So we just do successive powers of 10. If we're converting to hexadecimal, each position is going to be a successive power of 16. So if I had 5 slots here, this would be 16 to the 0, which is 1, 16 to the 1, which is 16, 16 squared, which is 256, 16 cubed, which is, I believe, 4,096. Let's see. 16 to the 4th, which is 65,536. And if we needed more, we could just keep going, but I'll stop there. If we need more, we'll come back and get them. The other thing you need to know about hexadecimal is that the way the counting works is we have all our normal symbols, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but then when we get to 10, this would be A. So we start using the letters of the alphabet to represent all the numbers up to 15. So this would be 10, 11, 12, 13, 14, and 15. Of course, when we get to 16, we would put a 0 there and then put a 1 in the next spot over. Just like in base 10, when we get to 9, we put a 0 and then put a 1 in the next spot over. So, how are we going to go about converting this number to hexadecimal or base 16? Well, what we'll do is we'll look at our powers of 16, and the biggest one that's still smaller than our number, we're going to start dividing with that. So if you look here, the 16 to the 4th is actually 65,000. That's larger than the number we have. So we're not going to need any lots of 16 to the 4th. That's too much. So we're going to start with our 16 cubed, which is 4,096, and we're going to do division over here. So I'll say 4,096 into 59,951. So 4,096, that's going to go in once to 5,995. Write that down. Do your subtraction here. 2 minus 2, that's 9. 18 minus 9 is 9. 8 minus 0 is 8. 5 minus 4 is 1. So now we have 1,899. Carry the 1. This, let's see how many times that fits in. 4,096. That's going to fit in. That's going to fit in 4 times. And that's going to give us 16,384. Do this subtraction. I'll go ahead and use the calculator since I got it right here. So 18,991 minus 16,384. That's giving me 2,607. Okay, notice at this point I don't have any more places to carry down unless I were to start doing decimal numbers, and my remainder is smaller than my place. So what I've got here is that there were 14 times that this went into the number, 4,096, with a remainder of 2,607. Well, 14 is E. So what's going to go right here is E. I'm going to have 14 of 16 cubes. Okay, so now we go to the next power, which is 256. And we see how many times that fits into what we have left over, the 2,607. And we're just going to repeat this pattern. So I see that this is going to go into 260 one time. If I do this subtraction, we get 4. Bring down the 7. Notice 256 goes into 47, not at all. So that's 0. So 256 fits in here 10 times. The symbol for 10 is A, so I'm going to put A right here. Repeat the process again. I've got 47. Let's see how many times 16 fits into that, because that's the next position. That's going to fit in twice, which gives me 32. If I do that subtraction, I have 8 plus 7, which is 15. Okay, so this goes in 2 times. So notice we don't need one of the new hex symbols for that. That's just 2. And now, when we're at the end, our remainder is just how many ones place we have. So we have 15 ones, so that's the symbol F. A good way to know if you've made a mistake is if you get to the end and this number is larger than the base you're working in, something's off. Because the most you would go up to here is 15. If I had 16, this would be a 0 and I would add 1 more into this place. So that's a good way to keep track of your work. So, taking 59,951 in base 10 and expressing it in hexadecimal, you get the number EA2F. And that is this example.